LeetCode 224. Basic Calculator isn't just a parsing task. It mirrors real-world tools like interpreters, calculator apps, and even SQL evaluators. But if we attack it with brute force, things blow up fast. Imagine 100 million operations just passing a 10,000 character input. So how do we duck that disaster? Let's wade into the brute force approach first. It's not sleek, but it gets the job done and sets us up to understand the smarter strategy later. First move, strip out all the spaces. We want a tight, compact string that's easier to scan. With that cleaned up string in hand, we drop into our main evaluator. If it's empty, we cut straight to returning 0. We prep our variables, a pointer to track our place, a sign to flip values as needed, and a result to build as we go. From here, we scan the string character by character, ready to pass numbers, react to operators, and dive into parentheses. Hit a digit? We build the number piece by piece, grabbing every consecutive digit until we hit something else. With the number formed, we multiply it by the current sign and toss it into our running total. No index jump here, we're staying in sync. See a plus sign? That cues us to treat the next number as positive, so we reset the sign accordingly. If it's a minus, we flip the sign. This handles both binary subtraction and unairy negatives like -1. Spot an opening parenthesis? That kicks off a new sub-expression. We need to find its matching close before we can evaluate it. Once we find the full range, we evaluate that inner chunk recursively. Then we apply the current sign and add its result to our total. After each case, number, sign, or parentheses, we nudge our pointer forward to keep scanning. Once we've chewed through the whole string, we hand back the final accumulated result. To locate that closing parenthesis, we track open and close counts until they balance. That tells us where the sub-expression ends. If the parentheses don't match, we throw an exception. That prevents invalid expressions from slipping by unnoticed. This brute force method runs in big O of n squared because every recursive call builds substrings. That's costly. Space is also big O of n squared due to stack depth and string slicing. Deep nesting? Java's stack might blow up. Not ideal. Let's fix those pain points. Substring creation and recursion are our bottlenecks. Time to streamline with an iterative scan. We start fresh with 3 variables, one for our running result, one for the current sign, and one to build up digits into numbers. To manage nested expressions, we bring in a stack. It lets us save our state when we dive into parentheses and restore it after. We now scan the string one character at a time, ready to respond to digits, operators, or parentheses on the fly. When we find a digit, we update our number, shifting existing digits and tacking on the new one. That builds multi-digit numbers naturally. If a plus sign pops up, we finalize the current number, apply the last sign, and add it in. Then we clear the number and set the sign for what's next. A minus works the same way, but this time we flip the sign negative so the next number gets subtracted. With an opening parenthesis, we hit pause. We push the current result and sign onto the stack so we can jump into this new expression safely. On the closing parenthesis, we first apply any leftover number, then pop the last result and sign from the stack. That lets us plug the evaluated sub-expression right back into the outer one. After finishing the scan, there may still be a number waiting. We apply its sign and add it to the final result before wrapping up. This version runs in big O of n time. Each character gets visited just once. Space is also big O of n thanks to the stack, but we dodge the memory hit from creating substrings. It's fast, clean, and built to scale. Here's the full picture. The recursive method works, but it's clunky. Every parenthesis creates a new substring and stack frame, bloating time and space to big O of n squared. For big inputs, that tanks performance. The stack-based scan flips the script. One pass, no slicing, and smooth control with a stack. It mirrors how real compilers work, and it's exactly the kind of trick interviewers want to see. Master this pattern, and you'll be ready for anything from parsing config files to handling complex DSLs. Keep building those skills, and we'll see you in the next deep dive.